Okay, now we're going to start the actual registry. We've been talking about it for a while, so let's actually do something with it. So the registry is actually really just an HTTPS server like we've talked about. It runs on port 5000 by default. And what we're going to do is we're going to start it, and then we're going to retag an existing image that we have that we actually got from Docker Hub. And that's how you actually change where the registry, which registry is going to be used rather, is you're actually going to retag existing images. And then we're going to remove that image from our local cache, and then we're going to pull it down from the registry after we've pushed it up there. And then we're going to actually stop and recreate the registry to show how you can change the storage. And in our case, we're just going to use local storage, but there are lots of storage options that we'll talk about. And I want to make a real quick note on the registry and how it prefers TLS. So out of the box, Docker will not talk to any registry unless it's running proper HTTPS security, right? It wants to make sure that your authentication is encrypted and that anything else that's passed is trusted. And so we call this secure by default, right? You've probably heard that before. And it actually won't talk with the registry we're going to create unless we're creating it on the local host, which we are. That's how we're going to do it, is just running on our local host. So that's easy. We don't actually have to worry about TLS just to test this thing out of the box because, like most websites, registry doesn't come with TLS built in. You have to usually create your own certificate. But if you're going to do self-signed certificates for your registry, or maybe you're going to run it remotely without TLS, which I don't encourage you to do, but in case you need to, there's actually an insecure registry option that you would have to enable in the engine. And so we're not going to cover that here, but just to know that in production, if you ever need to do a self-signed certificate, that you would just need to enable that. And you'll get a good error back from Docker. It'll say, I can't talk to this registry because I don't trust it, kind of thing, if you try to do that. But today, we're just going to be able to run it with regular HTTP on port 5000.
I'll jump back to my local machine and do a Docker container run -d-p 5000, and it defaults to 5000 in the container. And then I'll just call it registry. And then we're using an image registry. Okay, and if I do a Docker container ls, you'll see that it's running. In order to use it, we actually use tags. So if you remember with our images with Docker Hub, we had to put them in the format of account name and repository name, but that's for Docker Hub. For any other registry, we actually need to label it with the host in there as well. So I'm actually going to pull something called Hello World because it's nice and small. When we run it, it just spits out some text that basically validates that that container ran. Perfect for this nice little example. What I need to do in order to push it to my local registry is I need to give it another tag that tells my daemon where it needs to send it. So we use Docker tag, and then the image I need to tag, and then where I want to tag it to. So 127.0.0.1:5000. I have to put the port in there, and then hello world. So this would be the equivalent of making my own official image at the root of my local registry. And if I do a Docker image ls, you'll see that the hello world here has two tags, and it's the same image ID because all I did was give it another tag. But then if I do a Docker push, it won't actually push the Docker Hub. It'll see that there's an IP and port there and push it up to my local registry. Okay, so now let's remove our local copy. So Docker image remove and Docker image. Okay. Oh, right. Can't remove the image because we've got to get rid of that container first. So Docker container rm, and that's the container that ran hello world. And now I can remove the image. There we go. Okay, so now if I do a Docker image ls, I'm sure that I don't have it, right? I don't have that image. And now I can do a Docker pull from that same location. And there we go. I've pulled down that image. Now the first thing, if you were going to run your own registry for your own reasons, the first thing you'd want to do is use a volume to store the data. In this case, we could delete the registry and use a volume to do the same thing. So if I was in this directory where I'm registry sample 1, I could do a Docker container kill registry, Docker container, remove rm registry. All right, so we've cleaned up our registry container, and let's make it again. Docker container run d port 5000. Call it registry again. And this time we're going to give it a volume, and we're going to use the pwd trick to give our current working directory, and then I'm going to put a subdirectory in here of registry data. And that needs to go to var lib registry. The last part is we're using the registry image. Now, this is technically a new registry with a new database, and if you did an LL on the registry data, there wouldn't be anything there yet. But if I took the image we just did a while ago and pulled it back down, you'll see we have the hello world still there. So if I do a Docker push again, it should push it right back up there. And now if I do an LL in the registry data directory, you'll see some information in there. And I just did a tree command that may not be on your operating system, but you don't actually have to run it if you don't want. It's a common Linux tool that would show me all the different paths here. And you'll see that it actually breaks things down into the data or blobs, which is the actual binaries that are inside the image, and then the metadata around it, which is the manifest and the tags and such. And everything is in their own SHA directories because we've got multiple layers going on here. So it's not really particularly useful for us to dig around in there, but it's interesting to see. So there you go. That's the basics of running a registry on your local machine. And then next, we'll need to secure it with some TLS and then enable some authentication.
All right, so that's the basics of running Docker Registry. Here are the major commands that we ran in this lecture. So you might want to pause here if you wanted to write any down or make sure that yours were correct. And now that you're done with this lecture, remember to clean up so you can start with a fresh slate on the next lecture. Now, what about Docker Registry in a swarm? So it's not actually much different. The nice thing is that we don't have to run a Docker run command. We can actually use a Docker service command like we're used to, or a stack file like we've talked about in a previous section. But it's going to work the same way as if we did on a local host, because we can actually just tell the swarm to talk to itself for the registry. So we'll use the same 127 address. And we don't have to enable the insecure registry because that's already allowed by the Docker engine. And the routing mesh basically allows all the nodes to talk to the registry as if it's local, right? Because that's kind of the magic of the routing mesh. And I just want to remind you that this is a persistent data container. It does store data that needs to last over time. So you will have to deal in a real world production kind of scenario. You're going to have to deal with a volume driver and how to deal and basically make a decision around how you're going to store the data. But we won't do that here. So for this example with Swarm, I'm actually going to change it up a little bit and not use the 3-node cluster that I had used in a previous section. We're going to actually use Play with Docker this time. And if you just go to play-with-docker.com, we're going to actually prove that we're not a robot. And then it's going to ask me some random questions. It might ask you, it might not. And then we're in. So recently, the Play with Docker enabled a new feature that makes it even easier for us to set up a test swarm. And that's under the wrench object. I guess that's a wrench. And you see that there's options here that are basically templates for setting up a swarm. So instead of showing you the swarm setup like we've already done, I'm just going to set up 5 managers, no workers, give it a second so it'll set all these up. And basically what we're going to start with is a 5-node swarm, and we're just going to run a registry real quick to show how it's pretty much the same thing as before. All right, so now I have 5 manager nodes, and if I did a Docker node ls, you can just see that I have 5 of them. So yay, we have a swarm. So let's actually just run the registry. But this time we're going to use the service create. I'm going to call it registry. We're going to publish it again like last time. Port 5000. And we're going to, the image is registry. There we go. Now we can do a Docker service
PS registry, and it says it's running. Now in Play with Docker, we get this nice little button that shows up whenever we publish a web application. It actually exposes the port and gives us a nice little friendly URL that we can go test that web app or web endpoint. But you know, with Registry, at the root of it, it is nothing. There's nothing that is returned other than an HTTP 200. What we can do, though, is with any registry, we can actually go and look at the catalog, and that'll return a simple JSON array. And you'll notice its repositories is empty. Now, we could have done this in the previous lecture with it locally, but let's just play with it a little bit here since we're in this easy solution with Play with Docker. So now let me do the same thing. I'm going to do a Docker pull as before of the hello world. And I'm now going to do the tag, remember, again. So we're going to say tag hello world. And then I'm going to rename it or re-tag it to a new repository, 127.0.0.1, 5000. I'm going to do a Docker push. Let me zoom this in so it might be a little easier for us to see. Docker push. And then we're going to do the 127.0.0.1. Okay, and now it's pushed that up to our repository. And the way we can actually check really quick is if we go to this other tab and I'll refresh, you notice that repositories now shows the name of the repo that is available. And as we add more to it, this would actually expand the array and we would see all of them there. And at this point, I could just do as before, run that image. It would work just like we expected and scale it up. To just prove that point, I can do a Docker pull Nginx. We can run a simple Nginx web server. Docker tag Nginx. And then Docker push. Push that back up to our registry. And then you'll see here that I have two now. I have two in my two repositories there. And then if I did a Docker service create, just like we do normally, right? We're going to do on an Nginx 8080, but this time I'm going to specify the image like so. So we're telling it we don't want to use the Docker Hub image, right, to start this service, and we want to use this. And now we're going to add in a couple of options. I'm going to actually do replicas 5 so that one Nginx will start on each node. And then we're going to do a new option that started showing up in the, I think this 1704, I believe, detach equals false. And this will allow us to actually see the command running in real time. And you'll see that it's preparing, which means it's basically downloading that image from the registry to the nodes, and then it gets ready, and then it's running. And there we go. We're done. Now, if I pull, now you'll notice up at the top, it's now showing the port 80 because it's a new service, and you'll see that I have it here, and it's working. So what's interesting about this is that when you're in a swarm, you cannot use an image that's only on one node, right? A swarm has to be able to pull images on all nodes from some repository in a registry that they can all reach. And I didn't mention that in the swarm section, but it's an important point because that means that you can't just build an image of your own on a local, like let's say in this case, manager 1, and manager 2 isn't going to be able to go over to manager 1 and get it, right? They all have to do push and pulls from a central repository somewhere. But because I ran the registry as a service here, they can all know how to access 127.0.0.1, and then the routing mesh will actually steer them towards the correct container wherever that registry is running on one of the nodes, and then it'll pull that Nginx image to all the nodes as they need to be there, right? So if we did a Docker service PS Nginx, you'll see that there's one running on each node, and you'll see that the image it's using is the one from our registry. Okay, so that's it for just showing off how Swarm is very similar with Docker Registry. And at the end, we kind of mentioned that a new tidbit that you need to make sure that your images that you use in a Swarm are just accessible in whatever registry they're going to be in. They have to be accessible by all nodes. And that should be obvious, right? Because the nodes can't share images with each other. They actually all have to pull them from a registry. And so they all have to be able to reach it. It just so happens that a routing mesh makes it much easier to run that. And just as a last little pro tip, if you don't have to run your own registry, as cool as it might be to do so, just use one of the hosted ones on the internet, right? They're redundant. They've got monitoring and all the proper stuff involved with managing the storage. And they're usually, especially if you're doing open source, most of them are free. If you're doing it for private reasons and need to store private images, most of them are very reasonable cost. I mean, very low cost to store your images. So whether you use an AWS or Quay or Docker Hub or a lot of the options out there, I would say try those first and only use your own registry if you really have some sort of maybe offline requirement where it has to be available without the internet, or if there's just some restriction of security that you really can't use any hosted platform, because it really just is one of those things where it's a utility and it's great when you can just rely on someone else to solve that problem for you. So I hope you play around with it and have some fun. And now that you're done with this lecture, remember to clean up so you can start with a fresh slate on the next lecture.